Hello, good afternoon, everyone. I'm very pleased to be meeting you here, all of you. And it looks like I'm the only thing standing between you and the coffee break, so we'll try to be a bit short. I will talk a bit of what we are doing in Luxembourg at LuxProvide with MeluXina, the national supercomputer of Luxembourg, and as part of the Euro HPC network. And to do that, actually, I will start with some of the with the mission that we have been given. And our mission was, well, not to be, although our needs are very much the same as many of you, we were not centered on a specific domain, not to do climate research or weather and climate research, not to go for life sciences, but to help the national ecosystem in multiple dimensions. To help actors from the space direction that are doing Earth observation or launching satellites and optimizing the resource allocation, to help life sciences too, to help Industry 4.0, and to do this via supercomputing resource, which, as we all know, has transformed over years. It's not the same type of platform that many of us are running today compared to what used to be there 5, even 4, 3 years ago. So for Luxembourg, LuxProvide was created with a mission to help the national ecosystem and to provide a platform that is able to onboard multiple type of use cases. And we're doing that in two ways, both by interacting very deeply with our users, multiple type of users, both from public administration, public research, and industry, and providing them facilities, platforms, and expertise that they need to use in their projects. So I'm very happy today that after 1 year and a half of MeluXina being available for users, that we have been able to run multiple type of use cases that are quite transformative, not only for Luxembourg in itself, but across the European ecosystem too. So one of the flagship projects of from the European Commission, as you may already know quite well, is Destination Earth. Destination Earth has been running on MeluXina for more than a year now. And this has not been ultra large scale executions, but development work that will help bring the two digital twins that ECMWF is bringing, one on climate and one on weather, to life. And to play between MeluXina at a petascale or mid-range level machine with the larger machines that are in the European ecosystem being brought up in the Euro HPC network. Another very nice use case, and this is really a flagship AI project, and as you may imagine, translating between all of the European languages is quite a challenging task. And the European Commission itself has a group that is producing tools for this kind of work. And this kind of work requires a lot of computational capability. So today we're very much talking of large language models, where there are a lot of projects that have been running in this direction for many years into the past. And one typical challenge is that first you need to do it and to learn how to do it and to do it well, and then you can optimize it. So the part of work that happened on MeluXina in the past was exactly in this direction. So bringing some models that are well known and trying to optimize them to have student models that are able to run faster and with good degree of accuracy, and learning from the deeper, the larger models. Another type of use cases that we've been enabling in the past period or very much tied to life sciences projects. So life sciences, both in the direction of combining theoretical chemistry with machine learning and AI concepts, and building databases of chemical molecules that are able to help you generate molecules with targeted properties. And this is a very nice binding that is very much in the news today, but a lot of this work is very heavily computational, data-driven too, and this requires a machine capable of doing this kind of workload. Another type of projects, and very much coming from the space domain, is from the Earth observation, in the Earth observation direction. So flood modeling and risk analysis, and we've just heard how important urgent computing is, but a lot of that work is then propagated, and there are new companies that are evolving in the ecosystem and starting to develop tools that they're able to provide to customers in the insurance domain and in different kind of new industries to be able to do this kind of work. From building, from construction, where can I put a new building? Am I at a risk of flooding today, where 1 year ago this was not the case? A lot of things are changing, and many companies are starting to take advantage of supercomputers to do this kind of work. So this is some work that we're helping on, and this is propagating this kind of use cases into the industry, where industry was not in the past taking advantage of these kind of facilities. Optimizing resource planning for satellite applications is also something that has happened with MeluXina in the past. In the pilots project and program of MeluXina, when the system was launched, this kind of work is tremendously complex. It's an NP-hard problem that needs to happen. There's a lot of algorithmic research that is involved, and for now, not a lot of data, but we are imagining that in the future, a lot of data could be needed for this kind of work as well. We are all talking of ChatGPT these days, large language models, foundational models that may be applied to a different type of data sets, not only not textual data or language data, but also to media, and apply to different kind of industries, which also require much different HPC than HPC used to be, in the direction of having a platform that can do inferencing, that can do training, and that can do model serving observation, so a full cycle of applications. And the software stack for that is going to be different, and the HPC platforms that are built for this is going to be different too. So all of these kind of needs are really in the market today, are user requirements to be able to onboard. People are not saying, you want to do just HPC. They will say, well, we want you to solve this problem, and maybe this part of this problem is you can do it with HPC. Maybe you need more very varied type of resources in your HPC platform than in the past, but this is something that we're building towards and that we have put on the agenda and our roadmap for too as well. MeluXina, as it was built, was one of the machines in the HPC network. It was, of course, the first large supercomputer built in Luxembourg for everyone to access. It has been a machine built with Atos, with Eviden, with DDN platforms too. So it's a very capable AI machine. So if you call it like that, it's a 500 petaflops of AI system. It is a heavily accelerated machine, of course, and this helped it reach very nice numbers in the top 500, but it's a well-rounded machine. So we are counting much more on its ability to drive computation and data analytics for the kind of projects that are coming from a wide variety of use cases. So not a machine tuned for a very specific, a single type of use case. The machine itself, and if you would come and visit us in the data center, will look very similar to this diagram. There's a CPU partition that enables running any kind of application. There's an accelerated partition that is really helpful for AI applications, large language models being run today very deeply on it too. There are multiple type of data tiers that are very similar to what we've seen in the prior presentation. So it's quite nice to see this kind of needs being reproduced and the kind of solutions and solution design coming to play between all of the HPC centers across Europe. And the one element that we've done from the beginning on this machine was to create a partition for running cloud workloads. And it's this partition that we're transforming today to be able to bring new use cases to life. The machine is really very well connected to all kinds of data sources, and especially from the space direction. Companies, organizations that are active in the space domain are starting to ask us if we can bring direct connectivity into the machine to be able to transfer large data sets and how to process that well. So this is kind of nice use case that we're seeing for the future. In terms of sizing, just to have some numbers that are maybe useful for the more technical people around. The machine was built, again, with these multiple data tiers, and there have been an accelerated data tier where you can flush data to, or you can run it's a high IOPS, high bandwidth applications, and you can really drive a lot of use cases for AI out of this platform. But this is also coupled with a capacity tier and also backup tier for the applications that really require this level of redundancy. All of them Lustre-based file systems with data moving services that are linking them together. What we have deployed in the last year was actually an S3 interface to our mainline storage. So not dedicated S3 object storage, but gateways in front of our mainline storage. So we're seeing what kind of use cases people are able to get out of this and how they're going to be able to run containerized workloads or Kubernetes based in nature from our cloud, on-premise cloud partition into our main computing partition, all of it under supported by a unified storage platform with those differentiated data tiers behind. So this is just a very tiny brief insight into what we've built in Luxembourg and what we want to do. Maybe to highlight this point very deeply is the part that we're really transforming our cloud platform. We are very open to seeing what kind of use cases people will run and knowing that they're looking today for many more cloud-like uses of supercomputers that have been sometimes stuck very much into the past with a very rigid workflow manager, rigid batch job queuing system. So we're trying to play a bit between our cloud platform and our supercomputer platform together with our partners and to see how these two can really bring to life new kind of use cases on the machine. So very short, I promised I would be short. I hope I was a bit short. This was behind the mermaid of MeluXina. Hopefully there's also one question that I can answer before we go to break.
Well, any questions for Valentin? If not, I'd like to thank you very much again.
Thank you, Paul. Thank you all.
Thank you.